Hey there, I am going to walk you through part 2 of our HSPT prep. In this section, we're looking at fractions and decimals and converting them back and forth. So right now we're going to start out looking just at fractions. So here, a fraction is a number in the form of a numerator, which is the number on top, and the denominator, which is the number at the bottom, where y can't be 0 or 1, because if y is 1, it's going to stay the number it is, right? 3 over 1 is 3, 5 over 1 is 5. So it's an identity. And then it can't be over 0, because if you're dividing 5 by 0, you're not doing division. Because if I have 5 cookies and I give them to 0 people, I'm not doing a division math problem. So there's no division taking place. And where x and y are whole. So let's move on to definitions. Improper fraction. So in a proper fraction, not improper, but a proper fraction, the numerator is always less than the denominator. We know these. These are our old school fractions from 4th grade, where we have 2 over 5, 4 over 9, 1 over 4, good stuff like that. 2/3. Here you have 12 over 45. So it's always where the top number or the numerator is less than the denominator. Then we also have improper fractions. And improper fractions is just what it says. They're improper. It's when the numerator is equal to or larger than the denominator. In this case, they give us an example of 7 divided by 4, or 7 over 4, 8 over 3, 36 over 36 over 5, and 9 over 9, because this is 1, it's improper. Then the next example is a mixed number. A mixed number is a whole number with a proper fraction remainder. So it's a whole number, and then there is a leftover. So in this case, there's the 8 with the 5 over 9. There's 2 and 3/4, and there's 15 and 7/8. When we want the reciprocal of a fraction, we always invert it. It means we flip it. I think that's what we commonly say. So 5 over 3, the reciprocal is 3 over 5. 1 over 7, the reciprocal is 7 over 1, or just 7. If it's over 1, you can just get rid of the imaginary denominator. So let's move on and cruise on through fractions. So for our first example, they ask us to match the two columns. So for our first example here under fractions, they ask us to match the terms in the 2 columns. So they want us to match up who's the improper, who's the proper, and who's the mixed number. Well, first and foremost, we should already know that the mixed number is obviously the mixed number. It's the fraction and the whole number. So it's this one. So 2 goes with C. That we should already see. And then which one is the improper? The numerator is greater. So improper, and then this one is proper. So we know 1 goes with C. Sorry. So then looking at our answers, we know 1 goes with B. We're right. 2 goes with C. We're right. And 3 goes with A. Pretty straightforward. So then let us move on to comparing and ordering fractions. If we want to compare fractions first, we have to change all the denominators to the same common denominator. That makes sense, because we can't compare them if we don't know that they're the same units. So for this example, we are asked to compare 2/3, 1/2, and 3/4, and then determine which of the following statements are true. So if we're asked to compare these, we would probably want to convert them into a common denominator. And a common denominator here would be to change them all into 12. How did I magically get that number? I know 3 can get me 12. I know 2 can get me 12. I know 4 can get me 12. I would not pick 8 because 3 can't get me 8. So I know 3 times 4 gets me 12. So I know 2 times 4 gets me 8. So I know that's actually 8/12. I know that 1/2 in 12ths is obviously 6 over 12, because that's half. And then I have 3/4, and so that is going to be 9 over 12. Because I multiply my 4 times 3 to get me 12. So I multiply my 3 times 3 to get the 9. And then we compare these. So looking at this, is 2/3 greater than 3/4? Is 8/12 greater than 9/12? Nope, you're not correct. Is 6/12 less than 9/12? Yes, it is. So this one's correct. If we just looked at it, we probably could have looked at the answers first and seen that we did not have to convert. In hindsight, we should have looked at the answers first because I think we could have seen that just at the beginning. But you can also psych yourself out and do some weird stuff down here if you don't convert it. So this one was pretty straightforward. We all know 1/2 is less than 3/4. But just in case, I would say convert it to the common denominator just so you can compare. And if we look at their example down here, they actually did go through and convert them all, and then they compared them all and did their comparison, and they got the same answer we got. Okay, then our next part is reducing fractions. When we reduce a fraction, we keep the numerator and the denominator in the same ratio, but we make them smaller numbers. So we keep them in the same order they're in. So in this case, if it is 24/32, we're going to leave them in that order. It's going to be 24/32, but we need to reduce it to its lowest terms. And by doing that, we have to look at what's the GCF between 24 and 32. I know that 24 is 6 times 4. I know it is 8 times 3. I know 32 is 8 times 4. So it looks like 8 should be my GCF. If I look down here, they took 8 as the GCF. So I would divide both of these by 8. 24 divided by 8 is 3. 32 divided by 8 is 4. And that's how they get the 3/4. You don't have to write it all out if you do not need to. Don't waste time doing this if you can mentally already get it. So that was a really easy one to do. Let me cruise on to their next examples. So here we go. Here's some sample questions. Reduce the following fractions to their lowest terms. Totally cool. So we have 42/49. So what is our GCF between 42 and 49? What can get us 42? I know that 6 and 7 can get me 42. Yes? Yes. I also know 7 and 7 can get me 42. So what can I divide both of these by? I can divide them both by 7, and 42 divided by 7 is 6, and 49 divided by 7 is 7, so I already know it's A. How did I magically get that? I looked at the GCF between 42 and 49. That was it. And I knew my GCF was 7, so I divided both by it. If I look at my next one here, this one should be pretty straightforward. What is the GCF between 15 and 45? I would say it's 5 because 5 times 3 is 15 and 5 times 45 is 5. However, is there a better one to take out? There is a better one to take out. However, this is the HSPT. You're trying to take this test. You might be stressed out. So it's not the end of the world. So let's say we are in a moment of panic. We're taking this test, and the only thing we can think of is 5 because 5 times 3 is 15 and 5 times 9 is 45. Totally fine. Divide both by 5. That gets you 3/9. You can then double check. Is this really reduced all the way down, or is there a GCF between 3 and 9? There totally is a GCF between 3 and 9. It is 3. What's 3 divided by 3? 1. What's 9 divided by 3? 3, which gets us C. If you could have seen straight out that it was 15, then obviously 15 divided by 15 is 1, and 45 divided by 15 is 3. But don't sit there wasting time in the test. If you already know part of the GCF or a partial GCF, divide by it, get this at least reduced fraction, and then simplify it down again. There's no shame in that. And this will be more efficient than waiting and trying to figure out what the factors are. Okay, so then this one, we have 40 and 64. We need to find the GCF between these two numbers. 40 I know is 8 times 5, and then I know that 8 times 8 is 64. So if I divide 40 by 8, I get 5, and if I divide 64 by 8, I get 8. So I already know that my answer is 5/8. And I leave it at that. I don't have to do anything else. If I could do it mentally like I did, I would just do it mentally. I don't need to write it all out. Again, nobody is going to see your scratch work for those tests. And then just to double check our answers, yes, we were right. Then the next part is equivalent fractions. So we want to see if this fraction is equivalent to this fraction. So in this case, we want to see if 2/3 and 8/12 are equivalent to each other. So we're going to convert 2/3 into 12ths because we could compare it. So in order to get 3 to 12, you multiply by 4. So right here, they're multiplying 2/3 by 4/4. So that doesn't change the value, it's just changing the denominator. So 3 times 4 gets you 12, but in order to keep the same value, you need to multiply the numerator by 4 as well, which gets you 8. So now you can compare 8/12 and 8/12, and you see that they're equivalent to each other. This one. As a second example, let's determine whether 4/5 and 12/17 are equivalent to each other. So obviously 17 is prime, but what is the closest thing we can get to? I can turn this 5 into 15 and have something to compare closer to it, right? So that's what they actually ended up doing here. They multiplied 4/5 times 3/3, which then gets you a fraction of 12/15. And if this is 12/15, there's no way that it can be equivalent to 12/17 because you're talking about the same parts. There's 12/15 and 12/17. They can't be the same thing. So they're not equivalent to each other, which is why they put a little equals and an X out. So they are not equal to each other. I think they're missing a 1 right here because this should be 17, but whatever. So you get what I'm saying. Get the thing that's closest to it so you can compare it. And obviously, if it was multiple choice and you'd have options there, you would see the correct answer to choose. So then let's look at this. So they ask us to, oh my goodness, this one's so easy. Change 14. So next one, changing improper fractions to whole or mixed numbers. Obviously, you're going to divide. For example, 1, change 14/7 to a whole number. This one's easy. What's 14 divided by 7? It's 2. That's it. Don't overthink it. I don't even know how they got this extra fraction here. Do your math, do what you're supposed to do, and then move on. So then for the next one, example 2, they ask you to change 25/6 into a mixed number. We know this. This is back in the day stuff. If you really need to do it by hand, you can. You could do your 6 outside the box, your 25 inside the box. You know that 6 goes into 25 4 times because you get 24. And you subtract. You have a remainder 1. Remember that back in the day? So you end up with your 4, which is your whole number, which they got here. And then your remainder of 1 goes back over the 6. So you end up with that, which is how they got the 1/6. That's it. So you put your leftover back over the top. Or mentally, if you could have done it mentally, you would know that you take a group of 24 out and leave the 1/6 behind. Whatever is easier for you to do. If you need to write it out, there's no shame in writing out the math. If you can do it mentally, then just divide it mentally and have your leftover. It's all good. Again, nobody's beside you looking at your scratch paper or whatever. You're just doing the math that works for you. Okay, so then change the following improper fractions to mixed numbers. Okay, so we have 32 divided by 7. First things first, what is the closest product of 7 to 32? There's 4, right? Because 4 times 7 is 28. And there's 5. 5 times 7 is 35. It's obviously not going to be higher. It's going to end up being lower because the number is 32, right? Our numerator is 32. So we already know that the number that has to be out as the whole number in the improper in the mixed number is going to have to be 4. So we know it's one of these two. And then the only thing we need to figure out is what's left over, 4 or 3. 32 minus 28, we are left with 4. So it has to be this one. The next one, we have 46 divided by 9. Again, what is the closest product to 46 without going over? And that would be 9 times 5, which would get you 45, right? So, but it doesn't get us 46. So you're wrong because we're going to have leftover. You're too high. You're too high. So we know it's this one. By default, we know it's this one. But we also know 5 times 9 is 45. How many are left over? What's 46 minus 45? It's 1/9. That's it. Then let's look at this. We have 54 divided by 8. What's the closest number to 54 that we can get with 8? We can get 48, right? 6 times 8 is 48. And then 8 times 7 is 56. It's a little too high. So we're going to get rid of 7. We know that's not an option. Oops. We're going to get rid of 7. It's too high. So it's going to be one of these 3. So then we need to figure out if we multiply times 6 and we get 48, we end up with a little bit of math here. Again, if you already know off the top of your head, it's 6, then just stay with that. If you don't know it off the top of your head, there's no shame in doing a little bit of math to figure it out. So then our leftover is 6 over 8. My GCF in these two numbers is 2, right? 6 divided by 2 is 3. 4 divided by 2 is 4. It is this one. If worse comes to worse and you are completely stuck here, you should kind of see that this is too high. And then you would rule out between these two if you're really stuck. But this again is a little too low too. So this one, no, too. If you really had to rush to make that decision. But I'm saying do your math, get your simplified fraction, and then reduce it even more so. There is no shame in that. Then next one. Oh yeah, all right, we were right. Our answer was C. Then our next part, changing mixed numbers into improper fractions. So our example, they ask us to change 5 over 8 to an improper fraction. All we're going to do is it's kind of like taking your whole dollars and turning them into change. So we're going to multiply our denominator by our whole number, multiply these two numbers together, and then add the number on top in the numerator. So denominator by whole number, so we get a grand total of 24, right? 3 times 8 is 24, plus the 5 that was already on top, and we end up with 29 over 8. That's it. So 3 times 8, 24, plus 5 equals 29. And then it goes right back over the denominator because you are talking about the parts. That's it. That's all. So if we look at our next one, let me get rid of my mark here. Okay. So then let's look at the practice that they gave us. So they asked us to convert 2 of these. We can totally handle this. So for this one, they ask us to convert them to improper fractions. So I'm going to do that same cycle, denominator times whole number. So what's 4 times 5? It's 20. And then I end up adding 20 plus 3, which we could do mentally, but I'm just writing it out. So 20 plus 3 is 23 over 5. That's our answer. That's it. Same thing here. Denominator times whole number is 15 plus the number on top, which is our numerator. So 5 times 3 is 15 plus 2 is 17, and it's going to stay over 3. We are doing operations with fractions. So we're looking at example 1, where they ask us to add 2 over 3 and 5 over 7. These do not match. So they give us the answer here. We're going to ignore that because you're not going to get the answer on the HSPT. So we need to find a common denominator. This is, again, old school, 5th grade, 6th grade fractions. So we need to change 2/3 and 5/7 into something in common. So we're only looking at denominators. What do 3 and 7 have as a common factor? What's their, not common factor, I'm so sorry. So we're going to look at our denominators. What do 3 and 7 have as the lowest common multiple or the least common multiple, the LCM? Remember that? So we would like to get 21, because I know 3 times 7 is 21. Then I look at this. 3 times 7 is 21, so 2 times 7 is 14. 7 times 3 is 21, so 5 times 3 is 15. We have a common denominator, so we can add these two. It's the same fun stuff they did over here. We add it up. We get 29 over 21. And then we need to make it into a mixed number. So I know there's one group of 29 in 21. So I'm going to pull that one group out, which then leaves me with a leftover 8. So I'm going to put my 8 back over 21. And nothing else can get reduced here. So this is my final answer. So this one was pretty straightforward, pretty easy. Moving into example 2, they kind of take a big old jump here. So they are showing you an example of doing a division problem when you have a subtraction and an addition problem taking place in it. So there's actually 3 problems going on here. There's this problem first, this problem second, and then your overall problem at the end. So what we're going to do is simplify this part first and clean it up and get our numerator. We're going to simplify this, do a little bit of cleanup here, get our denominator, and then we'll do our division between the two. Sounds pretty easy. So I have 2 minus 2/5. So I'm just going to change one of my fifths. So I have 1 and 5/5. I'm changing it into fifths so I can do some math with it. And minus 2/5. So it's almost like I took let's say it's $2. I took $1, left it as a whole dollar because I don't need it. And I took my second dollar and I changed it into quarters, let's say. So I could do some math with it. So I do 5/5 minus 2/5, or 5/5 minus 2/5, which leaves me with 3/5. And my 1 wasn't even involved in this. It was waiting until I was done with my math. So I end up with 1 3/5 left over. Totally easy. And then because I'm going to do some more math with this when it comes to division, I'm going to actually make it into an improper fraction. So I'm going to do these two multiplied together, 5 times 1, which is 5, plus my 3, which gets me a value of 8/5. So that is my numerator. So this is on hold for right now. So my numerator is all cleaned up and nice. And they did that math over here too, if you want to see how they stacked it and did it all beautiful. Mine was kind of horizontal and doing the math the way that it worked for me, but you can look at their example over there too. Then the bottom is a little more complicated. We need to get a common denominator between 3/4, 3/4, and 4/5. Yes, we can cheat and look over on the side where they did the math, but we should also know what's the common denominator between 4 and 5, or what is the common multiple between 4 and 5? It's 20. So I know my denominator is going to be 20. I'm going to do 4 times 5 gets me 20. So 3 times 5 gets me 15. 5 times 4 gets me 20. So 4 times 4 gets me 16. I add these two together. So 15 plus 16 gets me 31/20. So that is my total for this one. Okay, then. We're not done yet. That's okay. We're going to finish up this last part. So I have 8/5 divided by 31/20. Really? So this is what our big problem is. So far we simplified the numerator, we simplified the denominator, and now we just got to do a little bit of division. So here's where this rule that we always know and love for doing division of fractions comes in. So if I'm going to divide fractions, I know that I'm going to keep my first fraction the same, because when we divide fractions, we end up making more parts. We change it to multiplication because we're making more little pieces. And we use the reciprocal of the second fraction, which means we flip the fraction upside down. I kept my first fraction the same. I made my problem multiplication now because I'm dividing to get more parts. So I change it to multiplication. And then I flip my original fraction to the reciprocal so that I can do my multiplication / division for this. So then I'm just going to multiply straight across, or I can do factoring. Whatever makes you comfy. If you feel you're going to do something weird in your factoring, then don't do factoring. If you feel that you're going to do something weird in your multiplication straight across, then do some factoring. So we're going to look for factors we can take out ahead of time. Is there a GCF between 8 and 31? No. So they're going to stay the way they are. Is there a GCF between 5 and 20? Yes, there sure is. It's 5, right? So 5 divided by 5 is 1, and 20 divided by 5 is 4. And then all I'm going to do is multiply straight across now because I already simplified. So 8 times 4 is 32. And then 1 times 31 is 31. So we end up with 1, right? Because there's one group of 31 and 32. Because 32 minus 31's 1 over 31. So I have one group of 31 in this whole group of the numerator of 32. So that's where I got my whole number 1 with a leftover singular 1 that I drop down and I leave over 31. So all that hard work and we get this answer. Now you might be thinking to yourself, oh my gosh, if all the problems in the HSPT are like this, it's going to take me forever and a day. But the other problems we did before were fast. And if you looked at part 1 of my review, those were fast too. So you're going to have these problems that are going to drag out and take a lot of time, but that's also why you want to be efficient in the ones that are not that time consuming so that you do bank a little more time for these problems. So then let's look at our next problem. For example 3, Pedro brought a candy bar that weighed 3 3/4 ounces. If he ate 2/3 of that bar, how many ounces did he eat? So we need to figure out what are they asking us to do here. They want us to find 2/3 of the bar. So of is our key word. Of always means multiply. So they're asking us to multiply these two together. So we have to multiply 3 3/4 by 2/3. The easiest way to do that is to change our 3 3/4 into a improper fraction. So 3 times 4 is 12, because I'm going 4 times 3 is 12, plus 3 is 15 over 4. And then I'm going to multiply it by 2 over 3. And then I could multiply straight across, which would be totally fine. However, if I do some cross factoring right now, it will save me some time later. So I'm going to look to see, is there a cross factor between 15 and 3? Do they have a GCF? Yes, they do. It's 3. So 3 divided by 3 is 1, and 15 divided by 3 is 5. Is there a GCF between 2 and 4? There certainly is. It's 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then we just multiply straight across. 5 times 1 is 5. 2 times 1 is 2. And then this is our final answer. However, if they want it in a mixed number, we would then divide these two. 5 divided by 2 is 2 with the leftover 1 over 2. And that's it. Then, for example 4. For example 4, we're being asked to simplify 4/5 divided by 2 and 2/5. Okay, this is totally straightforward, easy. Our 4/5 is good to go. It's set up the way we want it for our problem, so our 4/5 stays. We know we're doing division with fractions. Again, when you divide, you actually end up multiplying to get more parts. So we know our problem changes to multiplication. Then, because we're doing division of fractions, I know I need to flip my fraction to the reciprocal, but I can't do that when this is a mixed number. So I'm going to do my multiplying and adding method. So 5 times 2 is 10, plus 2 is 12. So I really know that this is 12 over 5. But I don't want 12 over 5 because we're doing division again. And I'm going to multiply by the reciprocal, which means I'm going to flip it to 5 over 12. Pretty straightforward, pretty easy here. Then I'm going to double check for cross factors. Why? Because it's easier to do it now than to do it later. So I'm going to just double check. 4 goes into 12 3 times and itself once. 5 goes into 5 once and once. Multiply straight across. 1 times 1 is 1. 1 times 3 is 3. It is 1/3. You could multiply straight across and get 20 over 60, which is 1/3. But if you can cross factor and make your life easier and do it early. Okay, so we're going to start out looking at our practice, and we're going to look at number 1. So they ask us to find 3/4 of 1/2 of 240. First things first, they ask us to find 3/4, right? So I know my 3/4 is going to be what I use. Nothing's going to change about that. The magic word of, which means multiply, right? And then what are we multiplying by? We're multiplying by 1/2 of 240. 240 divided by 2 is 120. So I know I'm multiplying by 120. That's it. It's no big deal. Don't make it Don't make it stressful, just divide by 2 because you need 1/2 of it. And then we're gonna do a little bit of cleanup math here. I know that there's a GCF between 4 and 120, right? I know I can divide both by 4. I get 1. I know I can divide this by 4. I get 30. And then I end up with 3 times 30, which is 90, over 1 times 1. Again, you don't have to write all this out. If you already see the 90, then you know it's 90. And that's it. And we're done with that one. Then the next one, they ask us to do a little bit of addition of fractions. We can handle this. It's not a big deal. So let's look. First things first, we got to get everybody into a common denominator so we can add them up and get them improper first and then do a common denominator. So I'm going to do 3 times 2, which gets me 6, and 6 plus 2 is 8. So I end up with 8 over 3. I'm going to do 4 times 3, which gets me 12, plus 1, which gets me 13. So I know it is 13 over 4. And then I'm going to do, oh, I don't need to do anything to this one. So I'm going to add 5, 6. Perfect. So I need to find out what is the GCF between, it's not GCF, I lied. Okay, and the 5 over 6 just drops down because we need to just keep it the way it is. So then I need to figure out what is the least common multiple between 3, 4, and 6. It is 12. I know that just from my practice of doing all this math. So I know I want to make all 3 of these 12s so I can add them up together. So then 3 times 4 gets me 12. So 8 times 4 gets me 32. Then I also know that 4 times 3 gets me 12. So I need to do 3 times 13, which gets me 39. Then I need to do 6 times 2, which gets me 12. I need to do 5 times 2, which gets me 10. So then I end up with 32 plus 39 plus 10, or really 49, because I'm just grouping those two together, plus 32, which gets me 81 over 12. So we end up with 81 over 12. Okay, so we've invested all this time. We did all this math. We added everybody up. We got 81 over 12, right? So now we're going to figuring out if we divide 81 divided by 12, what's our closest whole number? It's not going to be 7 because that's 84, right? That's too high. So it's got to be 6 because that's going to get us 72, right? 72 is 6 times 12, and that's going to work out that way. You do not have to keep going. You already know the highest value that you're going to take out of here is 6, so don't even worry about these. There's nothing to prove by doing the math even more. Like, 6 is the greatest group you can take out. That's it. You're done. Move on to the next problem. Then our next one. A beaker contains 12 and 5/8 ounces of alcohol. If 2 and 3/4 ounces is spilled out, how many ounces remain in the beaker? What remains? That means subtraction. So we're doing 12 and 5/8 minus 2 and 3/4. How nice that we can change this into 8, right? So I can change this into, instead of it being 3/4, if I multiply this times 2 and this times 2, I get 6/8. So I'm going to end up simplifying by borrowing here. So I made this 6/8. I can't do 5/8 minus 6/8. So I'm going to borrow. So I'm going to borrow from this 12. My 12 is going to become 11 because I'm going to take one group out of 8s out. 8 plus 5 is 13. So I really end up with 13 over 8 minus 2 and 6/8. 11 minus 2 is 9. This already eliminates this answer and this answer. So it's got to be one of these two. And my denominator is going to be 8. So I already know it's not that. I know it's this. It has to be. And there's no again, no word for going through and doing the math. I can if I really want to. What's 13 minus 6? Oh, yeah, it's 7. So, I mean, we're right. But those extra few seconds you do just to continue through, just for, I don't know, your peace of mind or whatever, don't worry about it. As soon as you start to see that the answer is there, choose that answer and move on. Again, there's no award for doing the math. Nobody sees your scratch paper. It's not going to count for anything. Then our next one here, we're being asked to divide. So 5 over 6 divided by 2 and 5/12. So first things first, my 5 over 6 stays. My mixed number here, I have to change it into an improper fraction. So 12 times 2 is 24. 24 plus 5 is 29. So this is really 29 over 12. But because I'm doing division, I'm going to end up multiplying, and I'm going to flip this to the reciprocal. So I end up with that. I can already see there is a cross GCF here. There's a cross factor. 6 divided by 6 is 1. 12 divided by 6 is 2. So we end up with 5 times 2, which is 10. I already see it. It's B. If I want to double check, oh yeah, it is 29. That's fine. There's no, again, and actually, even the moment I had done this part here, if I saw 1 times 29, I knew it was 29. I should have just picked it and moved on faster. And then here's one of those time-consuming problems. So it's okay, we can handle this. So we have 2 plus 3/4 divided by 1 and 1/4 minus 3/8. Totally fine and good. We'll do the numerator problem first. So we're looking at number 5. We have an addition problem in the numerator, we have subtraction problem in the denominator, and then we have an overall division problem. So I'm going to do my addition problem first. It's really easy. It's 2 plus 3/4, which is 2 3/4. Wasn't that difficult? When I do my next part, when we actually do the division, I do want this to be an improper fraction, so I can clean that up when we actually set up the division. Then over here, I have 1 and 1/4 minus 3/8. So I need to change this into eighths. You can do it just overall, which is fine. So 4 times 1 is 4. 4 plus 1 is 5. So you really have 5 over 4, which you can change it to eighths by multiplying by 2. And if you multiply by 2, you get 10 over 8. Right? So then you can use your 10 over 8 minus 3 over 8. So if I move on to that part, I get 7 over 8. Again, you don't need to write all this out if you can do it mentally. So I end up with 7 over 8 as my denominator. So I'm going to change this to an improper fraction. So 4 times 2 is 8. 8 plus 3 is 11 over 4. And then I'm going to multiply it by 8 over 7. And I'm going to look for a cross GCF. I do have a GCF here between 4 and 8. 4 divided by 4 once gets me 1. And 8 divided by 4 gets me 2. And then I just multiply straight across. I get 22 over 7. I don't even have to divide this. This is the only one that has the denominator that I want. So then I would pick B.